The next challenge we're going to be solving is the tip calculator. We're going to double click that Unity package, bring it into Unity here. We'll go into that scene and we'll double click the main scene file. And so here it's going to say, create a program that will calculate the preferred tip for a dinner bill. For example, your meal costs $20. We have 3 suggested tip values, 15%, 20%, and 25%. Include support for a custom percent tip and calculate the tip amount and total bill. Use the inspector to input your data. The example print should look like this. Your bill is $20, 15% tip is going to be $3 with a final total of $23, 20 and 25% are there. And then your custom tip of 18.5%, which is the custom input one, equals $370 with a final total. Okay, so we got a handful of things to solve here. And why is a problem like this important, and how does this relate to game development? Well, coding is the fundamental ability to research, solve problems, and break down problems to their smallest form. It's no different on whether or not you're building a simple tip calculator like this for the real world, or if you're building a homing missile. It's all about breaking these problems down to their smallest form. So here, when we look at this problem as a whole, it's quite overwhelming. But what we need to do is identify the first problem to solve and identify what is it that our program doesn't know. For example, our program has no idea what the concept of a bill is, or a total bill or final bill. It has no concept of a tip amount. It doesn't know what 15% or 20% or 25% tips are. We as software engineers have to define this information, and then we can use that to build this application. So before we get into which problem we have to solve first, let's create a new C# class called tip calculator. We're going to create a script here on a behavior. We're going to call it tip calculator. Once Unity compiles, we're going to attach this to the main camera. In the next video, we'll identify the first problem that we need to solve. So when looking at this problem, it's easy to get sucked into the problem as a whole. And what we need to do here is identify that the program to start, this is entirely based off the concept of a dinner bill. A dinner bill does not exist. It doesn't know what a dinner bill is. You, as a software engineer, have to define the dinner bill. And so as your first challenge, you are going to define the dinner bill. So we need to define the dinner bill once it's done loading. And then once we have a dinner bill defined, let's just go ahead here, and when we run the application, let's print out the dinner bill. So here, message to display what the dinner bill is. And that's all we want to focus on. That is the first step in solving this problem. I'll see you in the challenge review. In this challenge review, we're going to define our dinner bill. So here, our dinner bill is going to be a float value. So here we're going to define a private float dinner bill. And so once we have our dinner bill, what do we need to do? Well, we have our dinner bill defined. We can modify it in the inspector by adding a serialized field attribute. And then inside of start, we're just going to print that out. And so here we can see that the message here just says your bill is $20. So let's do that. Debug.log. We're going to use our new syntax with a $sign. And we're going to say your bill is, and we can append. We don't even need to. We're going to use our curly braces. And we're going to add the dinner bill here. We can now save this. Hop into Unity. We can select the main camera and change the dinner bill to be, let's say, $20. We can run the application. And we'll see here your bill is $20. Print it out right here. Your bill is $20. Perfect. I'll see you in the next video. Now that we have our dinner bill printing, the next thing we need to focus on is the 15% tip option. Before we get into the custom tip, the 20%, the 25% tips, we need to focus on just doing the 15% tip concept. And understanding, our program doesn't know what a tip amount is. It doesn't know what a tip is. You as a programmer have to define the tip amount. So that is a variable that we're going to have to define. We can say, hey, we're going to define a tip amount, and we can assign it to 15%, which is something along the lines of 0.15 for a percentage. Once we have our tip amount defined, we can actually then calculate a final total. And what is a final total? Exactly, what is it? The program literally doesn't know what a total bill or a final total is. You as a programmer, once again, have to define the final bill. The final bill needs to be defined by you, the software engineer, and then we're going to calculate the final bill. And we calculate the tip by saying the final bill, essentially, when we run the application here. After this, we're going to say, how do we calculate the final bill? We say final bill equals the dinner bill multiplied by the tip amount. So if the tip amount is 15%, this is going to give us our tip amount here. And you'll notice here that the final bill is just going to equal $3. That's obviously not correct. This is just the tip amount. So we can actually store that. For example, here's the tip amount, or the tip percent, we should say, right? So this is actually the tip percent. And then we have the final bill, but then we also have the tip. The tip is going to be returned and stored in something. So we need to calculate the tip. So you can say something along the lines of tip equals the dinner bill times the tip percent, right? So tip equals dinner bill times the tip percent. And then once we have our tip, we need to calculate the final dinner bill. And that final dinner bill is going to equal the dinner bill plus the tip. So hopefully that makes sense on what we need to do. Our goal here is to just focus on calculating a 15% tip. And then we want to print out a simple message of 15% tip equals blank with a final total of blank. I'll see you in the challenge review. In this challenge review, we're going to take a look at how to calculate the 15% tip. So inside of our code here, once again, we don't know what a tip percent is. We have to define that. And so what we can do here is create a float variable, and we'll call this tip percent. And I'm going to assign it to 0.15f, that's 15%. Once we have the tip percent defined, we also need to define the concept of a final bill. So here I can create another float variable of type final bill. And we'll equal that to, we don't even know yet, so it's just going to be undefined for now, defaulted to 0. We have our tip percent defined, we have our final bill defined. What we want to do now is calculate the tip. So here, we don't know what a tip is. We have to also define a variable to store the tip. So we have a private float tip. And now using these variables, they are going to be the building blocks for this application. We are first going to calculate the tip. So here we have calculate the tip, and we're going to say underscore tip is going to equal the dinner bill, which is $20, multiplied by the tip percent. And this is going to be calculate the tip 15%. So tip percent is already assigned at 0.15. That's our default. We now have a value of $3 here. And now we need to calculate the total bill. So after we calculate the tip, we now need to say calculate total bill. And so here, we're going to say final bill is equal to the dinner bill plus the tip. And that is going to be our final bill. From there, we can simply print out the message that we need. So we're going to say here, debug.log. We're going to use our new $sign syntax. And we're going to say here that a 15% tip is equal to, we'll go ahead and say tip. So a 15% tip is equal to tip. And your final bill is, I believe that's what it is, and your final total with a final total. So with a final total. All right, so 15% tip equals $3 with a final total of, and we'll go ahead and put final bill. And if we save this, we want to make sure that our parentheses are aligned here. We don't have any errors. Make sure we have our closing brackets. There we go. Okay, so debug.log 15% tip equals the tip with a final total of final bill. Let's save this, test it out, go back into Unity, hit play, and see if we are calculating the tip. And you'll see here that your bill is 20, 15% tip equals 3 with a final total of 23. And if we wanted to add the dollar signs, obviously we can. We can say, hey, 15% tip equals $3 with a final total of the final bill. We can save that, run this application one more time, and we can see now that we are successfully calculating a 15% tip. Now we can focus on how do we calculate the 20% and the 25%. And so here your bill is 20, 15% tip equals $3 with a final total of 23. Fantastic. Now that we have the 15% tip created, we can now focus on the 20% and the 25% options. Now, how do we go about doing the 20% tip? Our program doesn't know about a 20% tip. However, variables are called variables because they can vary. Right now, tip percent equals 0.15, but it could equal 0.2 somewhere else. And so here, I'm just going to clean up our comments here. Let's take a look at our full program here. So basically, we are calculating the dinner bill. We say, hey, your dinner bill is 20. We calculate the tip, and we say final bill equals that. And this is everything we need to do for calculating 15%. That's everything here. What that means is we could also start calculating 20% right here, where I'm going to go ahead and modify the tip percent. It's now going to equal, it will now equal, and we're going to place this here. Tip percent will now equal 20%, which is 0.20f. And so once we have our tip percent defined, we essentially are going to do the exact same thing. We're going to recalculate the tip with the new tip percent. You can see here that again, tip is a variable that we can just repurpose. It can vary. It currently equals $3 on the previous one, and now it's going to equal $4. So we're going to say tip is equal to the dinner bill multiplied by the tip percent. And that's going to give us our tip because now tip percent is 20. So we're going to get $4 here. And then we want to recalculate the final bill. So we're going to repurpose the final bill variable. And it's going to say equal to dinner bill plus the tip. And then we can retype out our debug.log, or we can copy this one here. If you're brand new to this, I don't recommend copying. Get the experience and practice of typing this out. So here we got debug.log 20% is going to be tip with a final total of final bill. If we save this and test it out, we should see here that $4 with a final total of 24 should be printed out. And there we go. We have 15% tip, 20% tip equals $4 with a final total of 24. And that leaves us to just one more. So hopefully you get the idea. So how would we go about calculating the 25%? I'll see you in the challenge review. In this challenge review, we're going to take a look at the 25% calculation. So here we have, once again, the tip percent, which is currently set to 20. We're going to repurpose that variable because it's called a variable. It can vary. We're going to repurpose it to 25. So 0.25f. Then we need to recalculate our tip based on that new tip percent. So we're going to say dinner bill multiplied by the tip percent. And then we'll also recalculate our final bill, which is equal to the dinner bill plus the newly calculated tip amount. So plus the tip. And then we'll grab this debug.log, and we're going to rename that to 25. And let's test it out. We'll run Unity here, and we can see that we have 25% would be $5 with a total of 25. Okay, fantastic. Now we have completed the 15, 20, and 25, and we can now focus on the custom tip concept. Your custom tip of 18.5%, and how do we go about even doing that? Keep in mind, once again, the program doesn't know what a custom tip is. You as a software engineer have to define the concept of a custom tip. And then once a custom tip is calculated, you need to come down here and do just that. So we want to be able to say, calculate custom tip. We don't know what the custom tip is because you'll be able to modify it directly in the inspector here. And so whatever that custom tip is, we want to make sure that we are calculating it appropriately. Now, that being said, when you do your custom tip, are you going to, on a user experience front, are you going to say 0.185 on an application if you were the end user? Absolutely not. You would just type in, hey, I want to tip 18.5, and you would type in 18.5, which means we need to convert the whole number to decimals, which means if the end user were to put in 18.5 here, we need to turn that into 0.185 for 18.5%. To do that, that's a simple mathematical operation of dividing this by 100. When you divide that by 100, we will get 0.185. So keep that in mind when we are calculating our custom tip. Otherwise, you're going to be multiplying the tip amount by a crazy number like 18. Okay? So hopefully that gives you enough to get started, and I'll see you in the challenge review. In this challenge review, we're going to take a look at the custom tip option. So like the others, the custom tip is not defined, so we must define it. So here, we're going to simply put private float, and we'll say custom tip. And from there, we'll serialize it so that we can see it in the inspector and modify it. From there, now that we have the custom tip, what do we want to do? Well, we want to calculate it. Now, before we calculate it, we need to ensure the custom tip is a percent. So obviously we're going to be accepting, let's say 18.5. So I need to make sure that the custom tip value essentially is going to be and let's make sure here, custom tip. I want to be able to access the custom tip is going to equal the current custom tip. So if I put 18, I'm going to say, hey, 18 is going to equal 18 divided by 100. And when we do this, it's actually going to then give us a decimal value. And I want to test that. So we're going to save our script, go back into Unity. And if I change my custom tip to 18.5, it should be 0.185. So when we run the application, the custom tip becomes 0.185. That's going to be super important for when we calculate an accurate tip. So the custom tip has been adjusted. And then now we're doing the exact same thing. So our custom tip percent there is essentially what that is. Now we can calculate the tip. It's going to equal the dinner bill multiplied by the custom tip percent. And then once we have that tip, we just add it to the final bill. So we're going to repurpose the final bill variable. And we're going to say, hey, final bill equals the dinner bill plus our new tip calculation. And then from there, we can simply do a debug.log. And we're going to say your custom tip, if we look at the message, your custom tip of blank. So here your custom tip of blank, and then what happens? And it says of, let's say 18.5%, so we put the percent sign, and then equals 3.70 with a final total. Okay, so equals, and then we're gonna have money, so blank, with a final total of blank. Blank, and that's also gonna be money. Okay, and then now all we have to do is fill in the variables. So your custom tip of blank percent. So we're actually just gonna put, for example, we're gonna say custom tip is going to equal the $ here of the amount. So we're gonna calculate that tip with a final total of the dinner bill. So here the final bill. All right, and if we save this, we should be good. Now I'm already foreshadowing that we're gonna have an issue where this custom tip is actually going to say 0.185%. And if that's the case, that's an easy fix. So let's check this out. And you'll see here at the very end, it says your custom tip of 0.185% equals 3.7. Obviously, I want that to read as 18.5% though. So how do we do that? Well, essentially what needs to happen here is after this variable runs, after we recalculate the tip, I no longer really need this custom tip value. I could convert it back to 100 by just multiplying it. If I got the current tip by dividing 100, by multiplying by 100, we'll set it back to the 18.5. So we could just do that. We're gonna say reset custom tip. And so to do that, we're gonna just access custom tip is going to equal the current custom tip, which is 0.185 multiplied by 100. And that's gonna give us back our full value. So now we can run the application and we should have a completed tip calculator. Your custom tip of 18.5% equals 3.7 with a final total of 23.7. And we are good. I'll see you guys in the next one. Something you may have noticed in your program is that the decimal place is 3.7 with a final total of 23.7. You may want it to say $3.70 with a final total of $23.70. For some reason, by default, our calculation of the tip here is only using one decimal place, and I'd very much like it to use 2. And this is a great opportunity to demonstrate, one, how to solve this problem by researching and trying out solutions. For example, I could say round 2 decimal places inside of Unity. But also, this is a unique opportunity to use potentially ChatGPT here. And you'll see here that I have found functions that truncate the decimal places, but I have the time in seconds. And you'll see here it's just for changing it to string, your float, .toString, f if you want the float itself truncated, your float equals, and you'll see here, you'll see some of this stuff where there's basically, you come across something that's like, oh cool, your float, which is custom tip, equals mathf.round, and then your custom tip multiplied by 100 divided by 100, which is going to give us the base 10 decimal system. And we could actually try, for example, this example. So the way we want to do this is we never want to just copy code. What we want to do here is really understand how and why this works. And so when we're calculating the tip, we know it's removing a decimal place. It's only giving us 1. And the internet says I can potentially do this. And as software engineers, we need to tinker with our own code and understand how this works. So we're going to say tip is equal to mathf.round. And this is going to be, I believe, after we calculate the tip, actually. So here we calculate the tip, and then we now need to round to 2 decimals. And so we're going to take our tip, which is 3.7, and we're going to equal it to mathf.round, just following the commented code here. And within that, we basically add the float value, which is tip multiplied by 100f, and then we divide it by 100f. And we need to understand, why are we multiplying and dividing by 100? And if we test this out and take a look, let's see if it works. And you'll see here that I don't believe it did work. Let's rerun this. We are still getting 3.7 with a final total of 23.7. So what is the issue here? And if we look at this, the tip gets calculated to 3.7, the tip equals mathf.round, the tip multiplied by 100f, 100 yada yada. So okay, so that didn't work. So what else can we try? Well, we're gonna take this line of code here, and this is an opportunity now to go to ChatGPT, for example. And so we can go to ChatGPT, and we're gonna say, this is returning 3.7. We want to be specific with the problem we have and how I'd like it to behave. This is returning 3.7, and I'd like it to show 3.70. I'm using C# and Unity. And let's see what it says. You can format the number to 2 decimal places in C#, and it's going to give us some options. And this looks exactly like what we just tried, but it didn't work. And we have this formatted string here. This will format the tip to 2 decimal places. So we say formatted tip equals underscore tip.toString f2. And it's basically converting the float to a string, which may be an option. And then here's how you might incorporate it into your code. It's saying, hey, here's your tip. And string formatted tip equals underscore tip.toString f2 for 2 decimal places. That f2 is just a built-in C# system. And if I wanted more information, I could say, can you write a complete beginner guide to formatting strings using toString, and what is the f2? And you'll see here that we can now learn more about how this is working. And so this is a great way to use ChatGPT to solidify your knowledge, 10x your learning and understanding, and become a fantastic software engineer. So what can we do with this information now? I can take this code here. And again, we're not going to copy and use this. We're not going to just copy and paste this code. We are going to make sure that we actually write the code so we can understand what it's doing. So here we calculate the tip. And then after calculating the tip, we're basically going to convert it to a string. So we're going to say, hey, string formatted tip is now going to equal the custom tip and a toString function, which is going to convert it from a float to a string. And we're going to pass in f2. And for some reason, that correlates to 2 decimal places. We can test it out. Let's go into Unity and see if that fixes it. Okay, so we just added that formatting thing, and we can see here that it still didn't work. So why not? Well, we're not actually using the formatted tip. So if I want to use that formatted tip here, I need to use the variable formatted tip. We're using the 3.7 still. I need to use the new variable called formatted tip. We can save that. Go back into Unity here. Test it out. And we now see $3.70 with a final total of 23.7, which means we also need to format the final bill. And so here, after we calculate the final bill, we're just going to go ahead and create another string for the formatted tip, but we can actually just repurpose, and I was going to say we could repurpose formatted tip, but it's already assigned to the formatted tip. So we're actually just going to create like a formatted final bill. So here we're going to say string formatted final bill, and that's going to equal the final bill dot toString to 2 decimal places using f2. Why does it work that way? That's just part of software engineering. We don't always know how or why things work the way they do, but this is how Microsoft works, and we just need to be able to find solutions and implement them into our code. That is your job. And so here we have our formatted final bill, and we'll go ahead and place that right here into formatted formatted final bill. I'm not 100% sure what it's angry about here, and there we go. Okay, we can now save this. Let's test it out. Run the application, and we should be fully set. And there we go. Your custom tip of 18.5% is $3.70 with a final total of $23.70. There we go. So that's going to wrap up the tip calculator here. And just off of what we created, we have 50 lines of code to create this simple applications. And what's really important to understand here is that you could have built this application in a dozen different ways. There is always more than one way to solve a problem. And what's more important than anything is that you just solve the problem. This is called brute forcing, the way we implemented this today. Is it the most efficient? Likely not. And I'm going to show you a more efficient way to do this in the next video, but it helps to understand how you get to the most efficient way. So many programmers think about how can I do this the most efficient way possible, and they think too much about it instead of just writing code to get a working result. Once you get a working result, then we can look for how do I now optimize this? How do I make this better? And so I'm going to tell you about some strategies that we can use to identify that, one, we can absolutely improve this, but then two, how to go about it. And when you go about creating software from the ground up, if you think about the most efficient way to do it first, you're not able to identify the lowest hanging fruit of how do I solve this problem. So we always want to brute force our way to a solution, or brute force our way to a solution, and then we go back and we refactor. If this is the implementation that you came up with, this is a fantastic way to do it, but there are problems with this implementation. Let's imagine you work for a restaurant and now your boss says, hey, we want to support 15, 20, 25, 30, 35, 40, and like 50 other tip options. Oh my goodness, it was so much work just to calculate these three. I now need to calculate all of those predefined ones? Of course you don't. Being a software engineer, we can actually optimize this to be very friendly, where we could actually take all 50 lines of code here and probably pack it into about 10 lines of code. I'm going to show you how to do that in the next video. In this video, I'm going to show you how we could increase or enhance the efficiency of this program. For example, let's assume that we wanted to define 50 different custom tip options. It doesn't make sense for me to copy this 50 different times and essentially recalculate for 30%, 35%, and so forth, right? I would be copying this so many times, and obviously that's not efficient to do. So what are the alternatives here? What other things can we do? Well, one of the things that we can do here is just increase how we do this. Right now, we're calculating things and we're repurposing variables. And instead, what we can identify here is, where is the duplicated code? How do I know I can optimize this? And the key to understanding how to optimize is first getting to the solution. So we did that. We brute forced our way there. Now the thing we want to identify here is, what can I optimize? And the goal here is to look for the duplicated code. We calculate the tip in the final bill over and over. And that tells me that I can modularize this. I can systematize this. The only thing that really changes is the tip percent, which means I can parameterize that. The tip percent could be parameterized. And so when we do this correctly, here's what it looks like. I'm actually going to delete all of this code. And I know what you're thinking. Oh, John, we just spent so much time building this. It's okay. It's part of this experience to get practice brute forcing your way to solutions so that you can think like a better software engineer in how to refactor it. So here's what we want to do. Essentially, we're creating a calculator program that we don't want to have any predefined tips. How about I have one function that can handle both predefined tips and custom tips? And the way we can do that is we can think about a function here. I can create a function called void calculate tip, and it's going to handle the entire operation for us. So when I call the calculate tip method, I want to be able to say your bill is, and anytime my boss is like, hey, we need to support a custom tip of 25%, I want to be able to just put a 25 in there, just like that. So calculate 25, or 25.5, whatever it might be. And so the way we do this is that 25 there is the tip percent. So we're going to calculate tip, and we're going to actually pass in now a tip percent as a parameter. So we're going to say tip percent. Now I'm receiving that tip percent as a 25 and a 30 and so forth. So we need to convert that to a decimal. So we're going to actually take that tip percent and we're going to equal it to the current value, which would be 10. Basically, if the tip percent comes in as 10, right, this is going to store 10. We're going to say 10 is equal to 10 divided by 100, and we're going to get 0.1. Now that we have our tip percent calculated properly, we can then actually calculate the tip. So we're going to say here the tip is equal to the dinner bill multiplied by the tip percent that we passed in. So we pass in a custom tip percent here. It's going to be 25 this time around. And then after that, we can now calculate the final bill, which is equal to the dinner bill plus the tip. And that is the completed program. If I wanted to add another one, I could now just copy this line of code, and the receipt could have a printout of all of the available tip options, whether it's 25 or 20 or 15 or custom 18.5. It's now going to allow me to just call this calculate tip function, and every time we do that, we are going to be calculating what it is. Now the last thing, of course, we need to do is print out the text. And so that is going to be done through our custom strings, right? So we debug.log. We're going to customize it a bit here for sake of time, but we're essentially going to say, we're going to go ahead and say here, we're going to say your bill is, we already know what your bill is. We're going to say your tip, or your tip percent, I guess, right? We're just going to say calculate off the tip. Debug.log your tip, and we're going to put that. Your tip in total, we'll put that. And so now we just fill it in. So your tip is going to be the underscore tip, and the total is going to be the underscore final bill. And we might need to do the string formatting if it's not displayed correctly. But here, you get the idea that I don't have to hard code and recalculate everything. We can use a function to efficientize this and modularize it. Now, if you tried to build this from scratch, starting with this concept, this is a much harder problem to solve. But we were able to break down the problem to its smallest form and build it step by step to where now we can think through, how do I efficientize this? So let's go ahead and save. And let's go ahead and test it out. And you'll see here that it's going to print out your tip is 5, 4, 3, and 3.7 because we're not using the string formatting, which you guys now know how to do. And so just like that, we have successfully completed our tip calculator.